In the previous video, I said that if you're told that x is directly proportional to y, you can think of it as a kind of a relationship between x and y. So it's a kind of relationship where if you double x, then you will also double y. If you travel x, then you will also have to travel y. If you half x, then you also have to half if you half x, then you also have to half y as well. So this proportional thing is just a way for us to express the relationship between x and y. So when you have this kind of relationship where you double this, then you double this. If you treble this, you treble this. Whenever you have this kind of a relationship, you can plot the relationships like this. So this could be x here, this could be y. So when you're told that x is directly proportional to y, then it's going to have this kind of relationship where it's going to be a straight line, and this straight line here, the equation of this straight line here is given by y equals kx. And this k here is a gradient of this line here, and this k is called the constant of proportionality. So whenever you have this x is directly proportional to y, you can visualize this graph. Okay, there are many instances in real life where one thing is directly proportional to another thing. You just have to look around nature and see if you can spot where one thing is directly proportional to another thing. So, for example, here, I'm not saying that people in a city is directly proportional to the pollution produced by the city. I'm not saying that. I'm just saying it could be. It could be. I'm not saying it is. Well, when you're older, maybe you can investigate this. The number of people in the city, is that directly proportional to the amount of pollution produced by the city? Okay, it may be a straight line relationship here. It may be this. So, or it could be something like this. If this is the case here, if it's like this, then you cannot say the amount of people is directly proportional to the pollution produced. You cannot say that if this is the kind of relationship. Whereas if you have this kind of relationship where the more people you have, the more pollution you have. If you double the amount of people, you double the amount of pollution. Then you can say that the amount of people in the city is directly proportional to the amount of pollution produced. Okay, or even if you have this here, you can still say the amount of people is directly proportional to the pollution produced. Okay, just look around nature and see if you can spot anything where one thing is directly proportional to another thing. So, for example, if you look at the animal kingdom, the mass of the animal, mass is like the heaviness of an animal. The mass of an animal, say if you have an elephant here and a blue whale over here. Well, the mass of an elephant, this here, as you move to the right, the mass gets bigger and bigger. So an elephant would be here, a blue whale would be here. The amount of food that an elephant eats may be that you could maybe argue that mass of an animal is directly proportional to the food intake, meaning the food it eats. So this you could put up a good argument for this. Maybe it's a directly proportional relationship. Maybe. I'm not saying it is. I don't think it is. I think it's going to be something like this. So in which case you cannot say mass is directly proportional to food intake. I'm not sure on this. So maybe when you're older you can investigate this. Okay. I think it's going to be like this. I'm pretty sure it's like this. Okay. So you cannot say mass is directly proportional to the food intake. Okay. Or maybe you could argue that let's say you could argue that the kneecap of a person is directly proportional to the height of the person. Meaning that if you look at a person, meaning that this distance here could be directly proportional to the height of the person. So if you know the height of a person's kneecap, you if this is truly the case, where the height of the kneecap is directly proportional to the height of the person, then by knowing the height of the kneecap, you can work out the height of a person. I'm not sure if this is true. Maybe you have to investigate. Yeah, but you could put up a good argument where the height of the kneecap is directly proportional to the height of a person. Okay, or maybe you could argue that the amount of money that a person has is directly proportional to the happiness of that person. Well, this is really hard to measure because you need to come up with a number for happiness. How do you measure a happiness of a person? You need to assign a number to a person's happiness. Now, how do you do that? I don't know. Money is easy. You can assign a number to money. Maybe the amount of money a person earns, or maybe the total amount of money that a person has. So, but this here is really difficult. I don't know how you would do this. But you do need to assign a number in order for you to investigate this. Okay, so here's an example here. What I do know is that the diameter of a tree trunk is directly proportional to its age. Okay, so now the minute I see this here, D is directly proportional to age. I know it's going to be like this. Diameter here, and then age of a tree will be here. Okay, I know it's going to be a straight line relationship like this. So I know it's going to be y equals m. Well, this is a straight line, mx plus c. But in this case, c is 0. That's why we forget about the c here. Well, this m is like the gradient. Well, so the minute you see this here, d equals D is directly proportional to age. You can imagine it's a straight line. This here, well, you got to figure out k here. Well, here you're told that the diameter of this specific type of tree here is 30, and when it's 30, when the diameter is 30, let me tidy this up. When the diameter is 30, the age is 50 years old. Okay, so you can figure out, well, so suppose this is the same type of tree here, this tree and this tree here. This tree here has a diameter of 40. How old is this tree here? Okay, so by looking, well, as soon as we know this, D is proportional to age, we can visualize this graph here, where this is D, the diameter, this is age. Now, just looking at this tree here, well, we know it's going to be a straight line. Okay, it's let's just draw it like this. The equation of this line will be y equals kx. Now we just got to work out this k here. But we're told that well, the minute you know any one point on this line, either here or anywhere on this line here, you can figure out the equation of this line. Okay, so we've been given this here, where we're told you've been told this, so you have to accept it. D, the diameter of a tree trunk, is directly proportional to age. Then we can jump to this graph here. But then we've been given this here. Well, when the diameter is 30, so meaning that when the diameter here is 30, this is 30 here, the age is 50. So this here is 50. So we know one point on this line. So we should be able to work out k. Okay, so now this is D. Put this into this here is now D. Okay, x is in our case now is D. So we can put this into the D here, and then this is y, or which is age. We can put it into here. Okay, so this thing here will then become 50, because remember the 50 goes into the y, and well, we don't know k, well, and we're going to put 30 into the D. That would be times 30, but the number always goes in front. So it's going to be 30k, 50 here. Now, if you want to know k, divide both sides by 30. So it will be 50 over 30 equals k. And then divide top and bottom by 10. So it's going to be 5 over 3. So now we know k. Now that we know k, hang on, 5 over 3. Hang on. So this equation here is y equals 5 over 3x. Okay, because earlier we knew it was y equals kx, and then we worked out k by using this. Okay, so now we've got k, but basically we've got an equation now. So for this tree here, let's say this tree was 30, and then this here is 50. Okay, now looking at this tree is what we're trying to work out. The age of this tree when the diameter is 40. So you would look up 40 along here. Okay, 40 here, and then now it's basically us trying to work out the age here. We are trying to work out this age here. Okay, so well, we've got the formula already here. So now we've got the formula. So let's put this diameter here into this x here. So it will be well, if we want to know y when x is 40, then just put the 40 into the x. So it will be 5 times 40 will be 5 times 4 is 20, and then you've got the 0 there over 3. So the age of this tree is 200 over 3, whatever that is. Get your calculator out or whatever. Okay? So the height of that tree is given by this.